Hey everybody, this is Larry. This is me over Q4 of the weekly contest 426. Maximize the number of target nodes after connecting trees 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is very similar to Q3. I urge that you watch that video first. But also maybe not. Maybe it doesn't really matter that much. I don't know. But yeah, I mean Q3 is the shortest path thing where you have a K distance away. But Q4 is different in that you only care about that is even. There's no K. I almost kind of got suckered into it a little bit in that I thought it would be the same except for that n is equal to 10 to the 5th. So you have a hard problem or something like that with K. But it turns out, but I did notice that the output is different. So I was like, wait, they are different. And then so I was able to notice it. So luckily I didn't spend too much time on that. But yeah. So the key thing to note is that you only care about evenness. So because of evenness, you can color things very specifically, right? And also it's a tree anyway, so but really there's everything is forced is what I want to say. And what do I mean by force? I mean force is that there's no choice, right? So the way that I would think about it is for each tree, color each node black or white, right? And what that means is that all the black nodes will be even distance from all the other black nodes, and all the white nodes will be different. Will be even distance away from all the other white nodes, right? So that's basically the first key to notice. And once you realize that, then within the same tree, ignoring the combining thing, within the same tree, it should be straightforward to kind of just do the loop, right? Well, then how do you use the second one? Second tree. Well, the way you use the second tree is the same idea with Q3, which is greedy, right? You just want to maximize the node that you connect to. Except for that now, the cost of that node is different. We're not doing less than or equal to K anymore. It's just this odd even thing, right? Yeah. And that's pretty much the idea. And the thing is that, but they're two different graphs, right? What I mean by that is that you have a color for tree 1 and you have colors for tree 2. Sure, you may in your head think of them all both as black and white as I did, but you can also think of it as okay, tree 1 has black and white and then tree 2 has red and green or something. Maybe red and green because we are almost Christmas season, I guess. I don't know. So yeah, red and green and black and blue. Black and white, right? So then now the question is, do we get more colors connecting to the red or to the green? The logic, the formula is actually the same, so it doesn't really matter how you interpret it. And I knew this, so I knew that I didn't have to check. But just to be clear, it's a little bit nuanced, right? Because if you have a black node, you could connect to a red node. That means that if you have a node connecting to a red node, then that means that green is the color that you're matching the current node, right? Because you could kind of draw it out, it'll be two distance away. And if you connect your node with a green node, then you're actually counting the number of red nodes in the thing. Again, it doesn't matter because then it just changed the order of a max function. So, but that's the idea. And of course, I actually solved this in about 4 minutes or so. You could solve this very quickly as well. I actually most of it is copy and paste from Q3, honestly. So that, if you look at my Q3 code, it is basically the same thing. I did optimize a little bit during the video so we could kind of clean that up a little bit. So we can maybe say, because I did clean it up slightly for the adjacency list so that it's slightly shorter, right? So you have, and I want to say that this makes, having modular code very nice. But most of this is, so I start off with the template. So the first thing is that, okay, well, the only thing that I have difference is the coloring thing, right? So here we color by BFS because, well, the last problem we did it by BFS, so I just copy and paste. And the thing is that if you're in an odd color, or black or white or whatever, then the next node is just going to be a different color, and that's pretty much the idea. So I start off this starting at 0, and then I just do this thing where it's +1 mod 2, so you get the opposite color. And if infinity just means unvisited, maybe you could think of it as another color. Like some people think of it as black, white, and gray as a result, but I mean, it doesn't really matter, right? Like, it's just your mental construct. So then now we know that all the black nodes and all the white nodes, if you want to think of it that way, will be together. So that's why I return both. The order doesn't really matter because you could change the colors independently. So I wrote even nodes and n minus even nodes. And keeping in mind that we only do one breadth first search. So in Q3, n is 1,000. In Q4, n is 10 to the 5th, which is too big for n squared. But we also only need to do it once, because if you think about the parity or the colorness or whatever, is that, well, all the black nodes you're already done, right? All the black nodes will be even distance from all the other black nodes, so you only have to do it once. And by the same logic, by that one token, all the white nodes will be even distance from all the other white nodes. So also, so doing it once is sufficient, so I get to be even and odd. The reason why I have an extra D is just to get our color for it so that it matches the even or odd, so that we can kind of, so that we can actually solve the problem, I suppose. It returns the colors for all the nodes. And basically, if color sub I is equal to 0, then we have even one here. If color sub I is equal to 1, then we take care of odd. It just kind of matches what we have here, where this is just the index of 0 and this is the index of 1 or something like this. And yeah, and in a greedy way, like we said, we take the max of whichever color that gives us the better solution, both on the even and odd. And that's pretty much it. Yeah. The adjacency list thing is going to be linear time, linear space. The BFS is also linear time and linear space for one core, but we only call it twice here, so that's pretty easy, right? We only call it twice, and that's pretty much it. And this other final piece is just a linear loop, right? You actually probably could even save this down to variable. I don't know, I was rushing it at this point during the virtual contest. And that's pretty much it. I'll make it slightly smaller, so hopefully I can fit most of it in one screen. Oh, I did fit in one screen. And that's pretty much it, right? Linear time, linear space. That's all I have for this one. And by that I mean n plus m, to be more precise. But yeah, that's it. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye. Again, another wrong answer. Okay. And then 1,000 people have gotten it. Oh, is this the same problem? Okay, so at least we got that, but n is bigger. Okay. I mean, this is just the shortest path, so okay. Let's think real quick. Why is this answer different than this one? Oh no, it's a different problem. There's no K. Okay, so actually read the problem first, Larry. Okay, so they're actually different problems. Okay. Number of edges is even. Okay. Why is this not bold? I feel like that's a very boldable thing. Okay, so I mean this is easy then. Yeah. Okay. Okay. Let me just copy some code for the setup at least, right? And then, how do I want to think about this? I mean, it's just coloring, right? Graph coloring or tree coloring or whatever, but maybe I even do this, really. Except we just do it once, right? We have, if d sub v is equal to infinity, then okay, and then now we just return count. Nope, count doesn't do anything, right? So even is equal to 0. Something like this, right? So we do a BFS on the second graph. Yeah. Yeah, okay. there's no K. And then, okay, so into R2. I have to make sure that we're right, but I think this is fine. This is mostly done, I think. Yeah, okay, so then we want to do even 1, odd 1. Yeah, okay, that sounds fine. I have to return something else. E1 and right, so something like this. So then now we have if color I. Okay. So then now we care about even 1. So even 1 plus. I guess you always just greedy? I guess so, actually. Maybe I'm wrong on this one. Yeah, okay. Well, we'll see if I am actually right. But, I mean, that could have been a variable, but... Eight, 7, 8, 8, 3, YOLO. I could see why people got this in 6 minutes. I watched Q2, so I got this in what? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, everything in between, the explanation, maybe not. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.